If you are interested in Angular architecture, if you value good practices, if you work on large complex projects, we have something special for you. For the second time in history, we have started a special program, Angular Architecture, Strategic Design, with NX. This is an extensive video course, combined with live sessions, which has already been joined by over 120 participants. You can find out all the details at angularmaster.dev. The program is time-limited, so don't wait, be sure to check out now what we have prepared for you. Visit angularmaster.dev website and see you on the other side of the screen.
What's up everyone, this is Dariusz Kalbarczyk, co-founder of MG Poland, JS Point, AngularMaster.dev and WorkshopFest.dev. Welcome back to Angular Master Podcast. Today, together with Manfred Steyer, who is an excellent speaker, trainer, consultant and author with focus on Angular, we will talk about Auth for SPAs and Micro Frontends. Hi Manfred, how are you today?
Yeah, I'm really fine. I had a day off today after attending 2 conferences in a row. And so hopefully I'm relaxed and I'm really looking forward to our topic today.
Perfect. The main reason we meet today is authentication.
Yeah.
You started a blog series where you tell us that the browser is not a safe place for storing security tokens. However, it's quite modern to directly use JWT tokens, OAuth 2 and OpenID Connect in the browser. What's the reason for this?
Yeah, so you are right with both. So it's quite common nowadays that we directly use security tokens we get via OAuth 2 or OpenID Connect in the browser. We directly use them with JavaScript. And while this is quite straightforward, the thing is, we can quite easily steal tokens from a browser-based application. There are so many approaches for cross-site scripting. And if you say, well, cross-site scripting is not a big topic anymore because we know about it for 10 years, then I have to tell you, well, it's still on the OWASP top 10. It's on position 3. And this tells us, while we know about cross-site scripting, it is still quite a topic. Attacker use this topic to get into your applications. It's currently on position 3. It's part of the injection attacks category there. And that means if we get, let's say, a bad dependency, this dependency could steal our tokens and send them to a bad website, to an attacker. Or perhaps if we have some issues with encoding and decoding stuff, it would be also possible to steal our tokens. And that's why even the OAuth 2 working group is meanwhile recommending against using tokens in the browser if somehow possible. There are several best practice documents that will be incorporated into the next version of OAuth 2. It will be OAuth 2.1, and they recommend against it if it is easily possible, or if it is possible. Let's skip the easily.
So, do we need to panic if we still use tokens in the browser?
Normally not. As always, it depends. It depends a lot on your threat model, on about which attacks you are suspecting and which attacks are possible or which attacks will be potentially. If we talk about an internal application, then normally it's fine to go with tokens in the browser, because there you have a different threat model. But as mentioned, you have to evaluate against your threat model, because only you as the owner of an application knows what can possibly happen. But for internal applications, I would say it's very likely that we don't need to panic, because there we need we know our users, and there we have a different threat model. But if you go with tokens in the browser, make sure you align with current best practices in the world of OAuth 2 and OpenID Connect. When we talk about public applications, well, in this case, it might be beneficial to move over to other approaches, because if your application is exposed to the web, then it's very likely that someone tries to crack it, to hack it, and to steal some access tokens.
But if we should not directly use security tokens in the browser, how to implement single sign-on with existing identity solutions like Active Directory?
Yeah, that's a good point. So the OAuth 2 working group is telling us that if possible, we should do everything in the backend. That means we do something like OAuth 2 or OpenID Connect in the backend. We send the user over to Active Directory or do some other identity solution via backend requests. And then the backend can store the retrieved token. And then the backend can also append this token to subsequent requests to our APIs. And that also means that everything the client sees is just a cookie the backend is giving us after it logged us in via OpenID Connect or OAuth 2.
But how to deal with APIs on different origins?
Yeah, that's really an issue, because if we go with cookies again, then all we can do is we can just use it with one origin, with the origin it came from. And that means we need to tunnel all the requests through this origin, and so we can access lots of different APIs on different origins behind our server. But we need to tunnel everything through this origin. In the easiest case, this just means we have some endpoints in our backend that forward our requests to the real APIs, and those endpoints will also more or less transparently append the security tokens. They will just append them to our calls that are forwarded to this or that API, to this or that origin behind ours.
You also mentioned that there is a way to use those ideas to improve security while making everything easier. So how is this even possible?
Yeah, it's indeed possible. I know at first glance, this sounds like a promise from bad merchants, those merchants that promise you everything. It will be better, it will be more secure, it will be easier, and you will be a better person at the end of the day. But in this case, it really works if we assume that we introduce a reverse proxy that sits in between your single page application and your API or APIs. I also call such a reverse proxy a security gateway. It becomes more secure because now we can isolate the difficult security tasks in this reverse proxy. That means we just need to implement it once, we can harden it, and then we can reuse it with different APIs and single page applications. Plus, it becomes easier because all the difficult tasks are in there, so we don't need to implement them time and again within our single page application and within our backend. And that's why it's both. That's why it's more secure and easier to use. The thing is, if we want to do something like this, our reverse proxy, first of all, needs to transparently forward the user to our login page, which is provided by an identity solution like, let's say, Keycloak or Active Directory in the cloud or something like Auth0. And then the reverse proxy gets via OAuth 2 or OpenID Connect, an access token, and several other tokens we need for security reasons. And those tokens are then stored in a server-side session in this reverse proxy inside of the security gateway. And now, if the client is accessing our APIs, then this access is also tunneled through the gateway, which is more or less transparent for the single page application. And when doing so, the gateway is just abandoning the token to this call before it is redirecting this call to this or that API in this or that different origin. So everything is more transparent. The client does not even know that there is a security token in place. It is just abandoned by the security gateway. And to remember this or that very user, also the security gateway is going with a cookie. And perhaps you're saying, yeah, but cookies are somehow not fun. Yes, perhaps they are not fun, but indeed, currently they are more safe than dealing with tokens in the browser, because there is a thing like HTTP only cookies that prevents JavaScript code from accessing it and from stealing those cookies. That means if you have a bad dependency, it's not even possible for it to steal your cookie because it's an HTTP only cookie, no JavaScript access. And there are cookies like same-site cookies nowadays that prevent nasty attacks like, let's say, cross-site request forgery attacks. And that's why currently using cookies for this is assumed to be more secure than just directly dealing with access tokens in your browser.
Let's assume we have installed and configured such a security gateway. What do I need to do on the client side for authentication and authorization?
Yeah, so the good message is you don't need much on the client side because everything happens automatically in the gateway, and so everything is quite transparent for the client. In my example application I've written for this, the authentication logic is just about, let's say, 15 lines of code. And at the end of the day, those 15 lines of code are just about asking the gateway about the current user. Because normally your single page application wants to know which user has logged in. And so we just need one call, one HTTP call to the backend, to the gateway. There is a special endpoint. And so the gateway can inform us about the current user that has been logged in. And it's a one-liner in Angular plus the boilerplate around it we need. If we want to explicitly log out, we need to have a redirect to a logout endpoint, also provided by the gateway. If we explicitly want to re-log in, or if we wanted to re-log in with another user account, then we need one more redirect to a login endpoint, which is also provided by the gateway. So it's really a piece of cake, very simple code for authentication on the client.
You're listening, Angular Master Podcast. Listen, code, repeat. Everything you need to know to become an Angular super developer.
And what do I need to do on the server side?
Yeah, actually, everything you need to do on the server side is to check the incoming access token. This access token is forwarded transparently by the gateway, and normally your server-side framework should have a convenience function for checking such tokens. Very often it's just a JSON web token, and if we think about ASP.NET Core or Spring Boot or Nest.js, there are existing convenience functions and libraries to do this check, and that's it.
Can you tell us a bit about your reference implementation for this idea?
Yeah, so To demonstrate this idea, I did a reference implementation. It's somewhere on GitHub. We can link it afterwards if you want.
Perfect.
And it is using ASP.NET Core with YARP. YARP is yet another reverse proxy. It's quite a new technology provided by Microsoft. And the idea is to give us a very customizable reverse proxy. The thing is, normally, I don't like reverse proxies at all, because normally it's about configuring them within a hardware solution or within a Linux-based server. And this is not what I like to do. There are other people that are more capable for this kind of work. And so normally I don't touch those solutions in a project. There are other people. But with YARP, it's somehow different. Because with YARP, I can use all my ASP.NET knowledge to write a custom reverse proxy. In my case, it's a custom reverse proxy redirecting the user to an identity solution, requesting this access token, storing the token, and appending it to subsequent calls that are forwarded to your API. So it's really a piece of cake and easy to do. And even though if you don't like ASP.NET, normally it runs in a Docker container. So normally you don't see it at all. Just start a Docker container with it and Bob's your uncle. However, I've also seen customers of mine who re-implemented this idea with other technologies like with Spring Boot.
What identity solutions does this implementation support?
Yeah, so I've tested it with 4 identity solutions. I've tested it with Azure Active Directory. I've tested it with Keycloak. A lot of my customers are using Keycloak nowadays. It's really a very nice solution for OAuth 2 and OpenID Connect. I've also tested it with Auth0 and with Identity Server, which is quite a famous approach in the world of .NET Core.
What's with cross-site request forgery attacks? Now, as we have cookies again, do we need to protect ourselves from them?
Yeah, in general we need, because otherwise the cookie could be misused by bad websites. The thing is, if we go with same-site cookies, then we should be quite protected, because a same-site cookie prevents that another website is misusing the cookies of our website by, let's say, opening an iframe pointing to our website, or by using an image tag pointing to our website, and so on and so forth. However, a same-site cookie is only protecting our site. And that means if we have a subdomain with a solution that is not really protected, with a solution that can be easily hacked, let's say a content management solution on another subdomain, then the same-site cookie does not really help a lot. And so if we have a situation like this, if there is the danger that we have a bad, or let's say a less secure application on another subdomain, we should go with cross-site request forgery tokens, which is just a random string that is sent to the client and then sent to the backend again when accessing this or that API. And the good message here is we can totally automate this. We can automate the creation of such a token in the gateway, in the reverse proxy. And there is a way to automate resending it to the backend within Angular. By default, if this token comes via a specific cookie, a cookie with a specific name, then the HTTP client is returning it automatically via a specific header with each and every call we are doing to our very own backend. So it's not a big deal. We just need to use the right cookie name and Bob's our uncle. Yeah, so it should not be a big deal. And if we don't have different applications on different subdomains, then a same site cookie should also be good enough.
Angular Master Podcast with Manfred Steyer cannot be complete if we skip the Microfrontends topic.
Yeah.
So does this approach also work with them, or do we have to adjust it?
Yes and yes. Of course, it totally works with a micro frontend solution. However, normally you do not want to send the same access token to all your microservices in the backend. Because if you just need one access token to access all the microservices out there, all the different subdomains, then you have something like a master key. And normally it's not good to run around with a master key all the day. Because if the master key is stolen, you really have an issue. Then the attacker can use this master key to get into each and every room of your campus, of your building, or in this case, of your solution. Then they can access each and every subdomain. And so what you normally do here is called token exchange. That means, first of all, the gateway just gets a very limited token. Just a limited token that gives you access to your key room. And then this token is exchanged for one specific access token, giving you access to this very subdomain. This is done if you want to access this very subdomain. And if you want to access another subdomain, your initial access token is exchanged by another access token for that very subdomain. That means you have just concrete access tokens giving you access to this or that subdomain. Or to come back to my metaphor, you don't need to run around with your master key. Instead, you are going to the key room and get a key that just opens this or that room for you. And at the end of the day, this is more secure because if something is stolen, the radius of possible actions the attacker has is limited. It's the principle of the least privilege.
Perfect. This was my last question today. Thank you so much for another great podcast with you, and hope to see you soon, maybe next week.
Yeah, see you next week. Have a nice weekend.
Bye-bye. Finally, please subscribe to our podcast, leave a like and a comment to help us continue to grow.